Today we're talking about representing inequalities. So first off, we need to know what an inequality is. So an inequality is a mathematical sentence that compares quantities. So for example, I could say that 7 is greater than 2. I'm comparing 7 to 2. I can throw in variables and say x is less than or equal to negative 15. And there can be more complex inequalities with multi-step equations. Maybe I say 2x minus 20 is greater than or equal to 50. So lots of different examples of how you could see this. And the important thing to know is that there are many values of the variable that can make the inequality true. So like for example here, maybe I'm saying the temperature is going to be less than or equal to negative 15. Well, there's lots of values that would be less than negative 15. It could be negative 20, negative 50, negative 32. Those are all going to be smaller than. So there's 4 symbols that we're going to use for our inequalities. These two right here, they don't have the line under it. They don't have an equal to part. This is just less than, and this is just greater than. And we think about it reading left to right. This number is less than that number. Over here we've got this line underneath. It's got the equal part to it. So this is not just less than, it's less than or equal to. This is not just greater than, it's greater than or equal to. So first now we're going to look at graphing inequalities on a number line. So the graph of inequality shows all the possible solutions. So we want to show not just one value that would work for it, but all the values that would work. So let's look at these 4 examples to kind of figure out what the different dots mean according to this problem. So this is representing x is less than negative 3. This represents x is greater than 6. This represents x is less than or equal to negative 2. And this represents x is greater than or equal to 5. And we're looking at these dots. So we're looking here, 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 and here. These two kind of have open dots. These two have closed dots. And if we look at the problem here, there's similarities between the inequality sign. These two are just less than, just greater than. There's no equal to part. And they both have the open dot. These two are less than or equal to, greater than or equal to. They have that equal to spot, and they have the closed circle. So, if we have less than or equal to or greater than or equal to with that equal part, it means a closed dot. But if it's just less than or just greater than, it means an open dot. And the way that I remember it is that here, negative 3 isn't included in our answer, so it's an open circle, versus it is equal to here, so it's closed, that negative 2 would be included. So, steps to graphing, there's a couple different ways that you can go about graphing these inequalities. We're going to go through one that a little bit longer process to it, but might be what works for you, and then we'll go through maybe a shorter way to do it. You're going to pick which way works best for you. So first, when we're graphing and we're making a number line, so we're going to order or label, really would be better, the number line from least to greatest. And we need to remember that the negatives are opposites of positives, so they work in the opposite direction. So when I'm looking at these examples down here, okay, we've got x is less than or equal to 58, y is greater than negative 36. So for the x is less than or equal to 58, when I'm ordering the number line, I want at least one number that's higher and one number that's lower than the 58. If I look at this, I look at 58 and say, what range of numbers is that between? Well, it's between 50 and 60. So I'm going to start my number line at 50, count up 1, 2, 3, 4, 5, label at 55, 6, 7, 8, 9, 10, label at 60. For the y is greater than negative 36. Well, I'm thinking of what range negative 36 is between. For 10, it's between negative 30 and negative 40. We have to remember, our negatives work in the opposite direction, so we want our smaller numbers here, which would be our bigger negatives. So we start with negative 40, 1, 2, 3, 4, 5. This will be negative 35. 1, 2, 3, 4, 5. That will be negative 30. So that was the first step. Now we're looking at step 2. It says determine if it is a closed or open dot. So what we're looking at is these examples. This has less than or equal to. Since it has that equal to part, that should be a closed dot. Over here, it's just greater than, it should be an open dot. And what sometimes people mix up is they put it above the line. You should be putting the open or closed dot on the number line. So for example 1, it would be at 58. So I'm going to find 58, 55, 56, 57, 58. This one's a closed dot, so I'm drawing a closed dot there. Over here, negative 35, negative 36, it should be an open dot, so an open dot right on that number line there. Step 4, it says determine which way you need to shade on the number line. And this is where it can get a little bit tricky, especially when our variable's not on the left side. So you can pick a value to the left of the dot, plug it in for the variable in the inequality. So I have a number that's to the left, let's say 50, I'm going to plug it in over here. So let's test 50. Is 50 less than or equal to 58? Yeah, that's a true statement. So if the above statement is true, we're going to shade to the left. So what that means is since 50 was a true statement, 50 is less than 58, I'm going to shade in that direction. But I should always double check on the other side as well. So if the above statement was false, I'm not going to shade to the left of the dot. Now over here, I'm going to pick a value on the right to double check. So I'm going to plug in a variable for that. So over here to the right, 60 would be to the right. So I'm going to plug that in. And then I'm going to check that statement. Is 60 less than or equal to 58? No, that's not a true statement. So since that was false, I'm not going to shade to the right. I only shade where that's true. So let's do that over here. I'm going to plug in, if I've got negative 40 compared to negative 36, is negative 40 bigger than negative 36? Think of temps as negative 40 a greater temperature, higher temperature than negative 36. Nope, it's not true, so I'm not going to shade this way. Versus if I picked a number here, and it could even be one that's not on the number line. Maybe I know zero's over on the side, so I could plug that in. But if I plug in negative 30, is negative 30 bigger than negative 36? Well, remember, a smaller negative is a bigger number. That is a true statement, so I'm going to shade in that direction. Here's way 2, and this is the way that I like to go about doing it, but you got to choose what works best for you. So this way I think is a little bit shorter. I don't have to plug in all those numbers. So for the second way, if the variable, so we're looking at our variable here, is on the left side of the inequality, then the inequality sign is pointing in the direction you need to shade. So first, let's start with our main steps here. We've got negative 2, so I'm going to think of what range that falls in here, and I'm going to graph. Well, that falls between negative 10 and 0. So negative 10, 9, 8, 7, 6, negative 5, 4, 3, 2, 1, 0. There's no equal to part, it's just less than, so it's going to be an open dot at negative 2. And since our variable is on the left, that inequality sign points in the direction I need to shade. If I think of it as kind of like an arrow, it's pointing to the left. So I'm going to shade to the left. Versus over here, if the variable's on the right side of the inequality, then an inequality sign is pointing in the opposite direction that you need to shade. So again, going to graph those points. We're looking at the number 6. That falls between 0 and 10. So this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's greater than or equal to. It has that equal to part, so it's going to be a closed circle at 6. And now, our variable is actually on the right side. So this arrow was pointing to the right, but it's the opposite, so it should actually go to the left. And if it's easier for you, you could rewrite this expression by kind of flipping it around, flip-flopping the 6 and the x. So the x would go on the left, the 6 would go on the right. Instead of it being greater than or equal to, it would flip to less than or equal to. And now if you look at it, okay, yeah, it points in the direction that it needs to go. So I want you to try these two on your own. Once we're done with this packet, I'm going to finish going through the rest of these. So right